So, we are on page 16 in your notes. And again, I think we're kind of done with the radical expressions. We can simplify, we can add, subtract, multiply, divide, all those things. Now we're turning to radical equations, things we can solve. We're going to get number answers out of these things. And honestly, throughout this entire section, 6.4, there's a whole lot of different varieties of these radical equations. We're going to start with things that are not fairly straightforward, but they're going to get a little more involved as we work our way through this section. And we're going to start with some radical equations that have one root in them, like what you see in letter A. 3 plus the square root of 2x minus 3 equals 8. Well, to solve an equation with one root, our first step is going to be to use some algebra to get the root by itself. Get rid of everything else. Step number 1 is going to be get the root by itself. To solve an equation with one root, first we're going to get the root by itself. And you know what? Let's stop for right now and go on to letter A and do that. I need to get this root by itself. Rowan? Absolutely. And of course, because you know how I am, show me absolutely everything you're doing with these equations. So show me minus 3, and you're going to get the little equation 2x minus 3 equals 5. We have gotten our root by itself. Hands to tell me how we undo a square root. Sai? Square both sides. What if instead we had a cube root? What would you do? Cube both sides. What I can kind of say in general is we're going to raise both sides to the power that is the inverse of the root. Step number 2 is going to be raise both sides to the power that is the inverse, the opposite, of the root. Get the root by itself, and then we'll undo our root by raising both sides to the inverse power. And I'm not going to give you the third step, but the third step is just finish what you're left with. It's going to be an easy little equation you can handle. So for this particular problem, square root of 2x minus 3 equals 5, we're going to do what Sai said, and we're going to go and we're going to square both sides. Squaring a square root is really nice. It cancels that thing out, just leaving you with what was under the root. So we'll say 2x minus 3 equals what number? Just say it. 25. And now you have a nice little equation that you can totally handle solving on your own. Of course, show me all the algebra as you're doing it, even if your name is Jack. Maybe 14? How about you try B? I think you've got to get rid of the 1 and then get rid of your 3. How would you get rid of the 3? Divide. Sure, it was a multiplication problem. You'll undo it by dividing. See what you can do with the whole problem. And again, show me all that algebra. This is how the homework's going to start. And if you already did it and didn't show the algebra, now go back and add the algebra in. Oh, by the way, yeah, this is probably a calculator problem. In fact, we're just going to use calculators for everything today. Were you able to get the fifth root of x plus 1 equals 3? Get rid of the 1, get rid of the 3. Next up, hands. Sora. With that thing, I can't hear anything. Yeah, exactly. How do we get rid of our fifth root? Let's raise both sides to the power of 5. And Sora, what is 3 to the 5th? Exactly, 243. X plus 1 equals 243. Minus 1, minus 1. X equals 242, I believe. Not terrible yet? Okay. Something weird happens sometimes when we go to solve these equations. And actually, we're going to see this in this unit with these radical equations. In our next unit, when we look at some rational equations. And in the unit after, when we deal with some logarithmic equations. Sometimes we get these things called extraneous solutions. Has anyone heard that word? Not like in a math context before, but the word extraneous before? And if you have, any clue what it means? And, yeah. Well, first of all, I think you do kind of see that word extra in there. These are extra solutions that aren't actually solutions. That makes no sense. Let me give you a definition, and then I think I need to show you what these are going to mean. An extraneous solution is a solution that arises when solving an equation that somehow isn't actually a solution to the original problem. An extraneous solution is a solution, and I think I'm going to put solution. Am I on the screen? I am on the screen. A solution, I'm going to put it in quotes, that arises, oh goodness, arises when solving an equation that isn't actually a solution to the original equation. An extraneous solution is a solution, an answer that you get that somehow isn't actually an answer. And I feel like that should make no sense at all. It's a solution that arises when solving an equation that isn't actually a solution. So you can see, that can help, that'll help, to the original equation. Sorry. Can you be a little louder? You were thinking getting rid of a square where we do our plus or minus, I bet. Yeah, totally different thing here. Okay, let's go on and deal with letter A. And then we're going to come back to this extraneous solution thing. First of all, I've got a 1/2 power in there. What does that really mean? Square root. So I had a square. How about I rewrite the problem with a square root in there? Because then it looks a little more familiar to me. And I feel like after that, you can totally go and do your solving. So go and solve that thing. I feel like the ones you've already solved were harder than this. 2x plus 1 equals 9. Minus 1 minus 1. 2x equals 8. Divide, divide, x equals 4. I think. Now, that thing I defined, those extraneous solutions. Solutions that aren't actually solutions. How could I figure out if 4 is actually a solution of this thing? Yeah, I'm going to go back to the original, and I'm going to plug it in and see if it works. And actually, why don't we go and fill in this little box here to determine if a solution is extraneous? We're going to plug it into the original equation and see if it makes it true. I am on the screen. We are going to plug into the original equation before we start doing any squaring or anything like that, and see if it makes it true. I'm going to go and I'm going to plug into the original equation, and I'm going to see if it makes it true. And I'm going to actually write out my kind of plugging in check work over here. Doesn't matter that the original had a 1/2. I can still just use a square root. So I'm going to say square root of 2 times 4 plus 1. And I want to see, I'm making up a symbol here, equal sign with a question mark, maybe equals. We'll see if it actually does end up equaling that. I want to see if it equals -3. Hold on a second. We're going to get square root of 8 plus 1, square root of 9, maybe equals -3. Okay, now I think I'm ready for you, Sai. What's the square root of 9? 3. You don't get 2 answers. You only get 1 answer. From that, square root of 3. A square root of 9 is 3. Does 3 equal -3? I don't think so. This is, sorry. You're thinking about if I want you to solve the equation x squared equals 9. If we have to undo a square, we take our plus or minus square roots. But if I give you something that already has a square root in there, the answer to a square root is only one number, just the positive number. Square root of 9 is only 3. Solve x squared equals 9, that's where you get your plus or minus 3 from. I did not do anything wrong in my algebra. These are not like wrong solutions because you messed up somewhere. It's because we kind of changed the nature of the problem from something with a root to something without a root, and we then get these solutions that aren't actually solutions. There was one possible answer that I got. It was +4, and that wasn't actually a solution. So what I'm going to say here is there is actually no solution to this problem. More with that in a moment. However, I should make a little note that says I got +4, I considered it, but it was extraneous. So I'm going to say no solution, but x equals 4 is extraneous. That's how I'm going to answer a question like this. There is no answer. I got 4, but I ruled it out because I tried to plug it in and I did not get good things. A few comments. And this is going to be annoying. It will get better in the next 2 units, but here the only way to check is actually by plugging in and showing all that stuff and prove to me that this number is or is not the same as that number. I do need to see that plugging in work. This problem, though, I feel like if you think about it for a moment, this actually makes sense why there's no solution. Square root of something equals -3. Can you take the square root of anything and get a no, which is why in this one there was no solution. In other ones, though, it's not obvious at all in the beginning, and we do have to go through all of our stuff and our check and all that stuff. I'm going to wait a moment. Anyone need another moment? Okay. They're about to get tougher. Page 17. Letter B. I want to solve the equation the square root of x plus 1 equals x minus 1. I already have the square root by itself. So I'm ready to go and get rid of my square roots. How? Sai? Well, both sides. We're going to go and we're going to square both sides of this thing. I'm going to square my square root. That's going to be nice and easy. I'm going to square my x minus 1 as well. What happens when you square square root of x? What happens when you square square root of x plus 1? X plus 1. Hands to tell me what's going to happen on the left. No, on the right. Let's go with Andrew this time. Were you going to say that, Rowan?
I was just going to say x squared minus a plus 1.
We're not allowed to do that. You're not allowed to distribute the square. What does x minus 1 squared mean? It means x minus 1 times x minus 1, which means then we're going to have to FOIL. Yeah, you're going to get an x squared, yeah, you're going to get a 1, but you're also going to get some other stuff in the middle that's going to matter. Can you guys please take a moment and go FOIL that thing? X squared minus x plus 1, so I think it should be x squared minus 2x plus 1. Oh, what do you know? This looks like it's becoming a quadratic equation. To solve any quadratic equation, we need this thing to equal 0. So let's get rid of the x plus 1 on this side so we can make it equal 0. Minus x minus 1 minus x minus 1. And we're going to get 0 equals x squared minus 3x. Well, I know it looks a little weird, but it's a quadratic equation. We can solve by either factoring or quadratic formula, get some answers, and then kind of go from there. This one we can solve by factoring in kind of a weird way. What am I talking about, Allison? Take out an x. We're going to get x times x minus 3. It's factored for us. Could you go a step further, Allison, and tell me the two answers? Zero and 3. Our factoring in this case was just GCF type factoring. If there was a number at the end, you do your multiply to the last number, add to the middle. We'll see some of those in a moment. But I've got two answers from this, 0 and 3. However, what else am I going to have to do? What? Did someone say something? Plug in, do your check. Now, they could both be good. They could both be bad. One could be good, one could be bad. No way to know until you go and plug in. So we need to do some checking here. You're going to check x equals 0. You're going to do square root of 0 plus 1. Maybe equals 0 minus 1. You're going to finish that, and then you're going to deal with x equals 3. And when you're done, see if you can write up what our solution is going to end up being. And again, I know it's annoying, but I've got to see that plugging in check piece. So what's good? What worked? Say that again? X equals 3 is good, because when we plugged that in, we got 2 equals 2. Yeah, that works. 0 didn't work, right? You got 1 equals negative 1. I do need to just show in the answer. I got it. I considered it. I ruled it out. So I'm going to say my answer is x equals 3. And 0 is extraneous. x equals 3, 0 is extraneous. Do you see why we had to FOIL in this problem? The x minus 1s. And then as soon as we start getting a square, we got to make it equal 0, quadratic equation, factor if you can, quadratic formula if you don't feel like it, and all that stuff. Letter C, again, don't be thrown by the 1/2. 1/2 just means square root, so letter C is like saying square root of x plus 2 equals 10 minus x. I want to see what you can do in letter C. I will tell you that it will end up being a factoring problem, but if you feel like the numbers are just, you don't want to deal with them, quadratic formula will work too. But see how far you can get in letter C. Very, very quickly. Sorry. You're welcome to move, by the way, for today, if you want. Oh my god. No, wait. No, I was good. 3 was good because I got 2 equals 2 over there. No. 3 is good. 0 is extraneous because 0 is the one that didn't work. Extraneous is the one that doesn't work. So I hope you're saying like x plus 2 equals 10 minus x, 10 minus x. Foiling, making it equal 0. It will be factorable, but if you're just not seeing it, quadratic formula will work for you too. And of course, once you are done, do your plug-in check. Hopefully x squared minus 21x plus 98. Again, if you see it, factor, great. I was able to factor. If you can't, quadratic formula will work. Who was able to factor? Dean, what do you have for your factoring? Yeah, That's going to work. X minus 14, X minus 7. Were you going to say that? So I think we're going to get 14 and 7 for our two possibilities. Finish this up. Do your plug-in check. If you get one that works, that is not good enough to tell you the other one isn't going to work. They could both be good. They could both be bad. You could have one of each. So you really do need to actually explicitly check them both. So I'm getting square root of 16 maybe equals negative 4. No, 4 does not equal negative 4. That's out. Square root of 9 maybe equals 3. 3 equals 3. That's good. So I'm going to say 7 is good and 14 is extraneous. Sam?
Is there ever a case where they could both be good, or is it just always
Absolutely. I think these were not the best examples for me to show you because they were one of each. But absolutely, there could be two good ones. There could be two bad ones. Absolutely. So you really do just have to check. I feel like that's going to happen in the homework at some point. Anything? Wait a moment. And then there's one other type. Oh. There's one other type of equation that I want to deal with today. And then we'll wrap things up. We're going to save the really nasty stuff, though, for Tuesday. You know what? I think I can do it like this. Okay. Next page. Page 18. I want to deal with some equations that have fraction powers. We've already seen some with like 1/2 and stuff. But if the power is more involved, like 2/3 or 5/4 or something more involved, it's going to be annoying to have to turn things into roots and powers, and there's an easier way to go about doing these things, and that's what I want to look at right now. For example, something like letter A, 3 times x plus 1 to the 2/3 equals 12. I know there's a cube root. I know there's a square. There's an easier way, though, to deal with this. To solve an equation with a rational exponent. First thing we're going to do is get the piece with the exponent by itself. First thing we're going to do, get the piece with the exponent by itself. Am I on the screen? Thank you. I don't always look behind me. So what are you going to do in letter A? Dean? Divide by 3, sure. Get the piece with that fraction power by itself, divide by 3. We're going to get x plus 1 to the 2/3 equals 4. This next step is the key step. What I can now do is I can raise both sides to the reciprocal, flip the fraction, power. raise both sides to the reciprocal power. I haven't done anything yet. The reciprocal of 2/3, flip it, you get 3/2. I'm going to raise this side to the 3/2, and I'm going to raise this side to the 3/2. Here's why. How do you do a power to a power? You do what to them? Multiply. What's 2/3 times 3/2? 6/6, which is 1. It's like we made our power cancel out. That's what we're trying to do. We're going to get 6/6, which is just 1. We just get x plus 1 to the first. Now, on the other side, we have to actually do that thing. How do you do 4 to the 3/2? What should you be thinking in your head? Andrew? Square root of 4, because our denominator is the root. Cube that thing. Square root of 4 is what? 2. Cube is what? You're going to get x plus 1 to the 8th. Step 3. Solve and, but check for extraneous solutions. Solve and check. And I think I want to finish this one together, and then I'll give you one to do on your own. -1, -1. X is going to equal 7. Maybe. For my check, I'm going to say 3 times 7 plus 1 to the 2/3 maybe equals 12. So that's 3 times 8 to the 2/3 maybe equals 12. 8 to the 2/3, so cube root of 8, 2, squared is what? What's 8 to the 2/3? 4? 16? 4, I'm thinking 4. Cube root of 8 is 2. Square 2, you're going to get 4. 3 times 4, does 3 times 4 equal 12? Sure it does. I was good. X equals 7 is the solution. You try letter B. And then we'll call it a day for today. By the way, while you're doing this, I do want to pass out the review packet for your test, because I only have one more day left with you guys on Tuesday. Thursday is our review day. Friday of next week will be our test. So let me get these up to you. By the way, if you notice, it goes from page 6 to page 8. There's a page missing. That's the graphic. Don't worry about that. We'll take care of that after. I do not feel like you need to be doing anything with these right now. You don't start till next Tuesday, that's totally fine. But if you are looking at a jump on things, you can start. Maybe the midterm review, though, would be a better thing to spend weekend time on. If you're doing 2 pages a night, you're going to be more than set with that. Okay, letter B. Go do things. Hopefully we can get x plus 1 to the 3/5 equals 8. And once you're there, time for your reciprocal power thing. Did you have to do 8 to the 5/3 in your work? What is it?
2 first and then 2 to the fifth to 32.
Perfect. Cube root of 8 is 2. To the 5th is 32, just like Rowan said. I shouldn't have done that. I shouldn't have circled it, because I got to do my check. Maybe 32 to the 3/5 plus 1 maybe equals 25. 5th root of 32 is 2. Cubed is 8. Oh, I think this is going to work. 25 equals 25. Sure, I'm good. Oops, you can't see that. But 31 is going to work.